All right, guys, in this exercise, we are doing the opposite of differentiation. We are integrating. Sometimes it's also referred to as anti-differentiation, sometimes also referred to as getting the primitive. We're going to use this formula up over here. So when we have a function, for example, x to the power of n with respect to x, when we integrate the function, the power, the exponent up there gets raised by 1. We simply add 1 to that, and then whatever we get, we divide by that underneath, and we add the integrating constant plus c. I've got a couple examples to show you, and both of them are fractional functions. And I'm going to show you the tricks to doing these. So let's have a look at the first one as I unveil it. It is the integral of 1 over x to the power 4, as you can see, with respect to x. So let's have a look how we're going to do this. Now, first of all, we've got to find a way to make it into an integrating friendly manner. So what I like to do with this 4 here in the lower part of the fraction is to turn it into a negative so it's easier for us to integrate. So let's do that. As you will know, I'm going to put the integral sign first of all because I want to simplify it. It's not integrated yet. That's going to be x to the power negative 4. Many of you already know how to do that. So now what do we do? As you look up at the formula, we raise the power by 1. So n becomes n plus 1. So if it's a negative number, it's a bit tricky now, we're going to add 1 to that. Negative 4 plus 1 is going to yield x to the negative 3. Isn't that true? And now we've got to divide by that also. So it's divided by negative 3 like that. So that's what the answer is, except for the integrating constant. So let's go ahead and add that. Plus c. So we can write that out in a different way that's a lot more simpler. We could also write it out as negative 1 over 3. Now, you'll notice we have the x to the power of negative 3. So because it's negative, it's going to be below or above the horizontal line. It's going to be below, isn't it? So let's extend that like that. The x will go right there, and it'll be to the power of 3. Well below like that. And then we can add the plus c there. So that's a simpler way of writing it. That's a negative right over there. Let me just box that up. Okay, let's try another example. Fractional function again. Right over here. Here we go as I unveil it. Okay, we have the integration of 2 on the numerator, and below in the denominator we have 3 and the square root of x with respect to x dx. Okay, so let's put it in integration friendly format. So this function will be transformed now, so we can write it out something like this. We can take the 2 and the 3 out, and I can actually write it like this. 2/3, and then put the integral sign, because the 2/3 are constant and we don't need to integrate them. They stay as they are when they're being multiplied, only when they're being multiplied. And this is going to be the integral of 1 over the square root of x. Now we can write that out in a format that's friendlier for us to integrate using exponents and powers, and that could also be written out as x to the power of a half. Isn't that true? That's the same as x to the power of a half, but negative. Why? Because the square root is on the denominator. So we're going to integrate this guy right over here. So let's write that out here. So I'm going to take the 2/3 again, and integrating that will give us, well, we're going to raise the power by 1. So negative a half plus 1 is going to give us positive a half. So that's going to be x power of a half. And then we have to what? We have to divide by that also. Let's do that. There you go, and there's a multiplication dot there. That's a times, multiplying. So let's further simplify this. Now, because we're dividing by a half and we're multiplying by 2/3, we can actually turn this upside down and multiply it and turn it into 4/3. 2/3 divided by a half is 4/3, and it's going to simplify times x to the power of a half, which is the same as the square root of x. Now, is anything missing? Of course, we have to add that integrating constant. So that's going to be a plus c right over there. There's our plus c. And now all we have to do is just box that up, and that's our answer. Well, there you go, guys.